Hello, hi, good afternoon. So today we are going to learn about refraction through a rectangular glass slab. This is like a very particular case that we are going to learn today, and we are going to apply what we have learnt in the last class. So I hope you guys remember what is the Snell's law, laws of refraction and refractive index. If you don't know, please go back and watch the previous class. Alright. So this is about me. I have PhD in physics from NUS Singapore, BSMS dual degree from ISA Pune, as ranker in JEE Advanced and KPY. Alright, let's start. So do you remember what is optical density? Hi Shubh, Jaiswal, Garahapura, Ayusha. Hi everyone, good evening. So now we have learned in the last class what is optical density. Optical density is nothing but it is very similar to refractive index. So it will tell, it is like a resistance which is provided to the light. So when the light passes from one medium, if it is a transparent medium, for example, if the medium is vacuum, it is called as optically lighter. So light can easily pass through it. So the speed of light is maximum in the rarer medium or vacuum. Hi Harshraj, Pallavi. Blur dikh raha hai? Maybe check your internet. Could be your internet problem, just check. So if the refractive index is lower, that means the optical density is lower. So rarer mediums will have low optical density and optically denser medium will have larger or greater optical density. So now if there is an incident ray passing from medium 1 to medium 2, there is a boundary. When this incident ray cross the boundary, what has happened here? So here in this case it is bending towards the normal. So if it is bending towards the normal, so what do we say? We say that this is the optically denser medium and this is optically rarer medium. Optically rarer means this N1 should be smaller than N2. So we can write N1 less than N2. So this is the meaning of optical density. Why only towards the normal? Yes, in the next one. Okay, so now this is one case. Now, so here the refracted ray bends towards the normal. And the next case, you see here, this is our incident ray falling at the boundary at this point. After refraction, what is happening? This ray is bending away from the normal. Can you see? It is bending away from the normal. So angle of refraction, this R is greater than I. If R is greater, so this medium is the rarer medium or optically rarer medium. So this is the second one, it is a denser medium. Again, this refractive index should be greater than this one. So we can write in this case N2 greater than N1. Okay. So now Gayatri, watch my earlier class. In the earlier class, I have done detailed calculations or detailed study on the Snell's law. So you can go back to the previous class, or else I can just give, there is a, like quickly I'll tell what is the Snell's law, but if you want, go back to my earlier class. So now what is Snell's law? So Snell, this person, he did a lot of experiments using light, and he came with the conclusion that this ratio is constant, sin I by sin R. So what is I? I is this angle of incidence, R is angle of refraction. So if you take the sine of those angles, this ratio is constant. And what people found out, this ratio is nothing but, if you know the refractive index, so this ratio is the relative refractive index. So what is N21? N21 is the refractive index of the second medium with respect to the first medium, and N21 can also be written as N2 divided by N1. So general form, this is the general form of the Snell's law. So how do you like write this? You don't have to remember. There is a first medium. There is a first medium, there is a second medium. So now the light, there is an incident ray is for going from the first medium. So this is the refractive index of the first medium, then angle in the first medium. So what we do is refractive index of the first medium multiplied by sine of the angle in the first medium. This should be equal to the refractive index in the second medium, which is N2. So this should be equal to N2 multiplied by sine of the angle which is in the second medium, R. So now from this you can get sine I by sine R, this ratio as N2 divided by N1, or which is simply N to 1. So this is the relative refractive index. Okay. Now we'll look the quick recap about trigonometry. Okay, hi, namaste. If the ratio of the constant, how is the speed of light change? So yes, speed of light will change, that is the reason ratio is constant. You can go back to my earlier class. Yeah, the wavelength dependent will do. This is for grade 10th, Gayatri. This is not for grade 11th and 12th. So we'll do whatever there is in the CBSE NCERT. Alright, and little more than that, not too much. So now if the angle theta changes, how the sine theta function change? Do you know? If let's suppose the angle is 0 degree, what is the value of sine 0? Tell me all these values. If the angle is, let's suppose 30 degree, 45 degrees, 60 degree and 90 degree. So this table you need to remember. Just remember this table, that would be very useful. Yes, it will depend on the wavelength, yes. Okay, so now what is 30 degree? So sine 30, so how do you know how to find out the 30 degree and 45 degree? So this, remember this triangle, this is 90, 30 degrees and 60 degree. So the opposite side of the 30 is 1, this is 2, it is root 3. So there is a trigonometry you will learn in details in maths, but this table what I am writing right now, it is required, so you need to memorize. Okay, for 0 it is simply 0. Then for 30, sine is the opposite divided by hypotenuse. So sine 30 is 1 by 2. Then we have sine 45, I'll come to this. Then sine 60. What is sine 60? In this triangle again, sine is opposite side divided by hypotenuse, which is root 3 divided by 2, and sine 90 is 1. Sine 90 is equal to 1. Now how will you calculate sine 45? There is another triangle. So there is an isosceles triangle as well as right angle triangle. So these two sides they are equal. So these two angles they are also equal. This is 45 and 45. Now assume that there is 1, there is 1. So this will be root 2. So sine 45 is opposite side divided by hypotenuse, which is 1 by root 2. So just remember this table. We'll need this. You will also need this if you have some numericals from the Snell's law. Okay. All right. Yes, correct. Nice. Jobless guy. Awesome. So this question I had given as a homework in the last class. I hope you guys remember this question. And did you solve, any one of you? Did you solve? I guess if you have solved, you can write in the chat. So here, this is a medium A. This is medium B. So what we want to find out? A ray is traveling from medium A to medium B. The refractive index of medium B relative to medium A, that we want to find out. So what we have to find out? Refractive index of B with respect to A, that is simply NB by NA. So this ratio you need to calculate. So how will you find out? So again, this is first medium, there is a second medium. There is an angle in the first medium, there is an angle in the second medium. You don't have to consider this. This is the normal, there is a normal. So angle, there is an incident ray and this is the refracted ray. So this will become our angle between the normal and the incident ray is our angle of incidence. And angle between refracted ray and the normal is angle of refraction. Okay. So now let's write down the Snell's law. So what Snell said, in the first medium, let's suppose their refractive index is, for this is the medium A, so refractive index is NA. There is a medium B, let's suppose refractive index is NB. So we want to calculate this ratio. So let's write down the Snell's law. In the first medium, refractive index NA multiplied by sine of first medium, that is sine I, which is, okay, I'll write down sine I, then NB sine R, okay. So you get this ratio NA by NB, which is sine R by sine I. But what is R? R is 45. So this is sine 45 by sine I is 60, sine 60. Okay, let's just find out what is this value of this. So NA divided by NB is, what is sine 45? In the previous one, I gave you this chart. Sine 45 is 1 by root 2 and sine 60 is root 3 by 2. So this is, it is sine 45 is 1 by root 2 and sine 60 is root 3 divided by 2. So if you simplify this, this will come out to be, multiply numerator and denominator by root 2. So it will come out to be, just multiply by 2. So it will come out to be root 2 by root 3. So this is NA by NB, but we want NB divided by NA. So from here, if you take the inverse, NB divided by NA is simply root 3 divided by root 2. So substitute this value here. So we'll get, this is root 3 divided by root 2. So what is the relative refractive index of medium B with respect to medium A? The answer would be option number A, which is root 3 divided by root 2. This was the homework given to you. If you have not done, please go back to the earlier class, understand what is the refractive index and other formulas. Okay. Hi Nithya and Trina. All right, great, correct. Now let's come back to our today's topic, that is refraction through the rectangular glass slab. So now, just a minute. So this is like a double refraction. So why I am saying it is double refraction, meaning double bending. So light is bending 2 times. You see here, this is the white light coming from this direction. This is the first point of incidence, that is the boundary between air and glass. So there is a bending of light at this boundary. Then light is going from glass to air. At this point again there is a bending of light. So at these 2 points there is a bending of light. That is why it is called as double bending. Okay. So now let's understand. So this is the air, which is optically rarer medium. Glass is optically denser medium. So this is angle I. So this should be the direction of the incident ray, correct? But when the light goes from air to glass, what happened? There is a bending and light has bent towards the normal because it is going from rarer medium to the denser medium. And when the light goes from the denser medium to the rarer medium, what happened? This should have been the path of the refracted ray. So this is called as incident ray. The second one here, it is called as refracted ray, and this is the emergent ray. this should have been the path of the refracted ray, but because light is passing from glass to air, that is going from optically denser medium to optically rarer medium, so it is bending away from the normal. So this is the optical density that we have studied. Okay, so there are these two types of bending that happens. So now let's learn some terms. So angle between this incident ray and the normal is our angle of incidence. This here is the angle of refraction R, and this is the angle of emergent, because there is a normal and emergent ray. So angle between them is angle of emergence, correct? Rarer to denser. Okay, so now this is a rectangular glass slab. What does it mean by a rectangular glass slab? That means all these angles are 90 degrees. All the angles are 90 degrees. So in that case, you remember there is a normal, this dotted line. So this angle is also 90. Even this dotted line is a normal. So this angle is also 90. Okay. So if I extrapolate these two normals, then you can see the three angles here are 90. For this quadrilateral, three angles are 90. So the fourth angle should also be 90. Even for this quadrilateral, three angles are 90. So this angle should be 90. So what do you observe? These two normals, they are parallel to each other. Can you see? Let's suppose I'll give some names here. N is here. So N prime, M prime, and this NM. So this NM and M prime, these two normals, they are parallel to each other. So I can redraw this. There is a normal 1, normal 2. So there is NM and this one is M prime, N prime. These two normals, they are parallel to each other, and between them there is this is our refracted ray. This is the refracted ray. So what was this angle here? This angle was angle of refraction. Angle between the refracted ray and the normal is the angle of refraction. So now, using the property of alternate angles, alternate interior angles, these two angles, they should be equal. So this angle should also be same. So if this is R, this is also R. Clear? Yes. Nice. Awesome. Correct. Alternate interior angles. Correct. So these two angles, they are equal. So just remember this. If this is R, this will also be R. Okay. So now at this point, let's suppose this is a point O and there is a point, let's suppose O prime. So can you write down the equation for the Snell's law at this point O? Until now, is it clear? So I'll remove everything. I'll need some space here. So at this point O, let's write down the equation for the Snell's law. So again, the first, there is a air. So refractive index of the air, let's assume it to be 1. Then refractive index of the glass, let's say it is N. This I, this R, this is also R, and this E. So at point O, let's write down the equation for the Snell's law. So first medium, refractive index is 1, then sin I is equal to the second medium, refractive index is N sin R. So we get this ratio, sin I by sin R, which is simply N. That is your standard formula for the Snell's law, correct? This is at point O. Now let's come back to this point O prime. So at the point O prime, let's write somewhere here. So at the point O prime, so now the first medium is the glass. So what is the refractive index? N. So again N sine of, what is this angle? This angle is R, should be equal to the refractive index. Again there is air, this is also air. So refractive index of the air is 1. So 1 multiplied by sine of E. Yes, so from here again we will get the similar equation, which is N is equal to sine E divided by sine R. Let's call it equation number 2. This is equation number 1. So here can you see this N is equal to this ratio, N is equal to this ratio. So because one side is same, the other side should also be same. Yes, if the other side is same, that means sine E by sine R. So I can write down this equal to sine E divided by sine R. So now can you see from here, these two are sine R, you can cancel out. If you cancel out, what do you get? Sine E is equal to sine I. So sine E is equal to sine I, and from here we get angle of incidence is equal to angle of emergence. So this is possible only when we have a rectangular glass slab. So this angle of incidence and angle of emergence are always going to be equal when you have the rectangular glass slab. So now let's learn more about this. You see, there is a complete diagram. There is an incident ray, then the refracted ray, emergent ray. If let's suppose there is no glass slab, what will happen? The incident ray will follow this path. This would be the path of the incident ray, and this is the angle of incidence I. This is R, this is also R, and this is this angle of emergence E. Okay. So here we have proved angle I is equal to E. So angle I is equal to E, and because of this, the incident ray and the emergent ray, they are parallel. So these two are parallel to each other. They are parallel to each other, and there is a distance between them. The distance between these two rays is called as lateral shift. So this lateral shift depends on the thickness. If you have very thin glass slab, the lateral shift would be smaller. If you increase the thickness, what will happen? The lateral shift will be larger. Okay. So yeah, that's it about the when the light passes through the rectangular glass slab. So now let's solve few questions. Solve this question. So here 4 students A, B, C, D, they trace the path of ray of light passing through a rectangular glass slab. They marked angle of incidence I, R and E as shown in these 4 figures. So now whose observation is correct? So there are multiple correct options. Choose all the correct options. Now look at option number A. So here this is angle of incidence, but here is there any bending of light? There is no bending. Can you see light should bend? When light is going from air to glass, there should be some bending of light which is not shown. So this is wrong. Okay. Now let's come to the last one. Again, in this one, is there any bending of light? Light is going from air to glass, but there is no bending of light. Light should bend. Because there is no bending, this option is also wrong. How about this one? So let's find out. This is our incident ray, then angle of incidence I, light is bending towards the normal, this is angle of refraction R, light is coming out, again there is a bending which is away from the normal, there is an angle of emergence. So everything is correct. So this is the correct diagram. Now let's come back to this. There is an incident ray, there is angle of incidence I, light is bending towards the normal. When it goes from air to glass, light is bending towards normal, which is correct. Now this R and this also R, both are correct. So this is light is bending away from the normal. When it goes from glass to air, it is bending away from normal. Even this is correct. So these two are correct options. B and C both are right. Okay, nice Nitya, Bimla, Aurora, correct. Awesome. Easy, right? Very easy. And you will get such kind of questions in your, some of these questions are from NTSE type exams. You will get similar questions even in your CBSE board exams. Now solve this. In the following diagram, lateral displacement or lateral shift is correctly marked in which of the following? Where is the lateral shift correctly marked? So in the first one, it is marked between these two arrows. In the second, it is between this normal and the refracted ray. In the third one, there is an emergent ray and there is an incident ray, direction of the incident ray, and this between, like, this diagram is not correct. So this is not correct. How are these two? Here it is between the normal and the refracted ray, which is not correct. How about here? Here they have not shown anything here. So they have not represent what is the incident ray. So even this is not correct. In this one, there is the incident ray, there is a direction of the incident ray, and there is an emergent ray. So this diagram is correct. Option number C, nice, correct, awesome. Now let's solve. Okay, so there are two things which are important. So let's understand that. So this is like bit extra. It is there in your NCERT exemplar, and some of the questions can come directly from these concepts in NTSE as well as in NEET or JEE mains exam. So be careful, like pay more attention to this. This is very easy concept but very important. So now what is critical angle? So what happens, let's assume there is a denser medium. Denser meaning optically denser. When we study the light, the denser medium means optically denser medium. So, okay, this is not working. Alright, so these three are normals. So let's find out what is happening here. So this is the incident ray. Can you see this is the incident ray? And angle of incidence is 0. Because of that, angle of refraction is also 0. So there is no bending. Angle of incidence and angle of refraction both are 0. Now if I increase the angle of incidence, so what will happen? So this is the angle of incidence, it is greater than 0. So this is a denser, that means the above one, this is a rarer medium. This is a rarer medium. Let's suppose N1, which is smaller than N2. There is a N2. So what will happen? Light will bend away from the normal. This is the R, angle of refraction. Light is bending away from the normal. But what will happen? There will be a case in which for a particular angle, which is called as critical angle, what will happen? The angle of refraction will become 90. So for this angle, the incident angle, angle of incidence, is called as critical angle. Okay, so in this case, let's write down the equations from the Snell's law. So say Snell's law says N2 is the refractive index of the denser medium multiplied by this sine of this angle, which is sine C, should be equal to the N1, which is the refractive index of the rarer medium, multiplied by sine 90. But do you know what is sine 90? Sine 90 पता है आपको क्या होता है वैल्यू? Sine 90 की वैल्यू क्या होती है? Sine 90 is 1. So here we get N2 divided by N1 as 1 by sine C. Or this is if, let's suppose, the rarer medium, if this one is air. If this is air, then N1 will become 1. If N1 becomes 1, from this equation, we can write N2 is equal to 1 by sine C. or sin C, we can write it as 1 by n2. So this is the critical angle. If you know the refractive index of these two medium, you can find out the critical angle for that particular medium. Okay. So now, yes, if this first medium, this rarer medium has a refractive index 1, we can write this equation. So from this, either if they have given the value of critical angle, you can write the value of refractive index, or if you know the value of refractive index, you can find out what is the critical angle for this case. Okay, let's now learn one more thing which is called as total internal reflection. Not understood? Okay, so which part you didn't understand? Bimla, Kumari, which part, which section you didn't understand? Again, I am repeating the angle of incidence. I am increasing the angle. If I keep on increasing the angle, earlier there is a 0, so light will pass without any bending. As I am increasing the angle, what will happen? The angle of refraction will also keep on increasing. This value will keep on increasing. So there will be a point where angle of refraction becomes 90 degree. So at this particular point, this angle of incidence is called as critical angle. For this case, I am writing the Snell's law. So there is a Snell's law, N2, which is the refractive index of this medium, multiplied by sine of critical angle, should be equal to N1, which is the refractive, there is a N1, medium 1, which is our rarer medium. This is a rarer medium, okay. So this N1 multiplied by sine 90, but sine 90 we know it is 1. So we get N2 divided by N1, just simply write this, N2 divided by N1 is 1 by sine C. Take this sine C to other side, sine 90 is 1. So you will get this ratio. And if this rarer medium is air, so if this is air, then N1 will become 1. N1 will become 1, and this is simply N, which is the refractive index of the denser medium. So you can write from here N is equal to, so N1 is 1, N2 is simply N, so N is equal to 1 by sine C. Okay. In the second line also it is becoming 90. What do you mean? If the second medium is not air, then this is a general formula. This is the general formula for the critical angle. But if the second medium is air, then N1, so this is the reason N1 will become 1 for the air or vacuum. We assume that the refractive index of air is 1, very close to the vacuum. So then only we can write this equation. This is for the air. Second line also becoming 90, what do you mean? So simply I am just substituting sine 90 is 1, sine 90 is 1. So substitute the values, you will get this ratio. Okay, Bimla Kumari. Now let's understand total internal reflection. Again, we'll do the same ray diagrams which we discussed like a couple of minutes back. So there is a denser medium. Let's assume that the denser medium is water, and the rarer medium. The rarer medium can be anything. It is just lower refractive index. Lower refractive index, and denser medium means higher refractive index. That is the meaning. Denser medium, so refractive index is greater. Rarer medium, refractive index is lower. So now this is the incident ray. This is the incident ray which is along the normal. So it will pass without any deviation, no deviation. Angle of incidence is 0. Okay, so now you increase the angle of incidence. It is going from the denser to rarer, going from denser medium to rarer medium. What will happen? It will bend away from the, it is bending away from the normal. So this one was the normal here. So bending away from the normal, correct? So this is the, and whenever the ray goes from denser medium to rarer medium, there is no 100% transmission. So maybe like 10% of light is reflected back and 90% of the light is refracted. So 90% of the light goes to the second medium and 10%, let's say it can be anything. So 10% came back in the same medium. So that is the, and this is the reflected ray, reflection or reflected ray. This is a refraction. So there is no refraction. So what will happen? Reflected inwards. So that is the reason it is called as total internal reflection. So all the light which falls at the boundary is reflected inwards, no refraction. Okay, yeah, so this is how it should be. So these are all partial reflection and that is the total reflection. All right, so that's it for today. Okay, so there are two conditions for the total internal reflection, that is light should travel from the denser medium to the rarer medium and the angle of incidence should be greater than the critical angle. If you follow these two conditions, then only you can see total internal reflection. All right, so that's it for today. Thank you so much everyone. Bye bye. बंद करो.